Lisp is well known for introducing the idea of symbolic programming, manipulating lists of symbols which represent things in the world as structured objects. So with Lisp, you could do more than just compute a number. You could manipulate whole equations. And for this reason, Lisp was the standard language for artificial intelligence for many years, and was also the standard language for any kind of automatic manipulation of mathematical equations, such as symbolic differentiation or automatically verifying proofs. And there's just one feature in the language that makes this all possible: quotation. Symbols normally refer to values, but sometimes you can refer to the symbol itself. If I define A as 1, then A is the symbol and 1 is the value. If I define B as 2, then I have a second symbol with another value. Now I can use those symbols inside of an expression, but the value that you get by evaluating this expression has no A's and B's in it. It's just a list containing 1 and 2. So we've lost all notion of what symbols were used to create this value. This value has no symbols in it. But quotation allows the symbols themselves to be values. Quotation is used to refer to symbols directly. If I make a list where I quote the A and I quote the B, always with a single quote, and never with one at the beginning and one at the end, but instead just one at the beginning of whatever I'm quoting, then I build a list containing the symbols A and B. If I build a list with the symbol A and the value to which B is bound, I get a list that contains A and the number 2. So as you can see, these quotes weren't necessarily paired. You can have just one quotation mark inside of a larger expression, and it quotes whatever comes directly after it. The quote is actually shorthand for a special form called quote, and so this would be equivalent to writing list quote A quote B. The special form indicates that the expression that is quoted is the value itself, as opposed to needing to evaluate that expression. Quotation can also be applied to combinations in order to form lists. So I can quote the list ABC, and that builds a list containing the symbols A, B, and C. The car of that is the symbol A, and the cutter of that is the list containing the symbols B and C. Let's try some more demos. Quoting A is the same as quoting A. I can use the value A in any way that I want. For example, placing it inside of a list, and I could do that using either syntax. The nice thing about the single quote is that it saves you a set of nested parentheses. When quoting a list, you get a list, but all the expressions within it are quoted as well. Now another way to build that same list would be to say, give me a list of 1 and the symbol A. If I were to attempt to build a list of 1 and A, it would tell me that A is not a known symbol because I've never defined it to be anything. I can't evaluate A until I've defined it, but I can refer to A even before I've defined it because it's just a symbol. It could mean something in the future, it just hasn't been defined yet. It's possible to quote a nested expression in order to build a list that has as some of its elements other lists. So perhaps try to figure out what is the car of the cutter of the car of the cutter of this quoted list. You're welcome to pause the video. I'll show you the answer in 1, 2, 3. It's the number 3. The cutter is a list containing as its first element the list 2, 3. The car of that is the list 2, 3. The cutter of that is a list containing 3, and the car of that is the number 3. And we could have told exactly the same story if instead of numbers, these were all symbols themselves.